Hi everybody. Thought I'd do a little quick video. Hopefully I can keep this quick on my progress with developing a RGB to VGA solution for the 1088 XLD. I basically have already kind of put some stuff up on the forums about this earlier. I started this project probably, I'm guessing, like about 3 or 4 months ago. And what I essentially did is I took a GBS-8200, which is a Chinese-made 15 kilohertz RGB to 31 kilohertz line doubling VGA board. And initially, when I tried it out, right out of the box, it actually does work. It does do the conversion, but the quality was really not that great, and I think it has a lot to do too with the strange video format that comes out of the Atari, which is not exactly NTSC or exactly PAL. It's kind of got some timing issues and what have you. So then I started looking around, like, well, is there some way that this can be made better? And I found a project online where people are basically doing that, and I found one that was based on, I think it was an AVR chip, and I based this prototype board on that chip and the firmware that was available on that website. And out of the box, it actually worked pretty darn good, but there were still a few things that were not quite right for our Atari 8-bits. So I wanted to get in there and kind of tweak some things. And originally I was thinking, well, I'll just tweak some of the preset codes, which are essentially the parameters that are going to be fed into the scalar chip. I'll tweak some of those to make it work better. And then the more I thought about, well, if I'm going to do that, wouldn't it be great if I could actually take this over into a PIC chip instead of the AVR chip? And that would let me use the Joy to PIC programmer to program that chip, as well as the ones I'm already programming on the XLD board. So all the custom chips would basically be programmable by the same system. So I did that, and here we see, this is just a breadboard right now, but that little chip in the middle there, that little 8-pin chip is a 12F1572 PIC chip, and I've actually got a program running in it now that reprograms the GBS board to be much better suited for our Atari 8-bits. Let me get my finger out of the screen there. Anyway, the programming system I used too is I wanted something that was pretty easy for other people to maybe come in later on and actually modify things as well if they wanted to. So I went with what's called Great Cow Basic. And I used this on the MIDI project before, and I really liked it. So I decided, well, let me give it a shot for this project as well. And actually, it didn't let me down, and I really like the end result of it, and it's really easy to work with. So if we come over here, we can actually see the the board, the GBS board running with the new firmware being put into it by the PIC chip. And it actually works pretty darn good. I mean, this is about as close as you're going to get to the quality that comes out of the Sophia DVI board. But in this case, you're going to have a lot greater compatibility with computer monitors. In most cases, you're not going to need to change the firmware that came with the Sophia RGB board, nor are you going to have to change the firmware after you flash the PIC chip in the GBS board, or I should say the GBS carrier board that I'm making. It should just work out of the box, and it should work with quite a variety of monitors as well. Right now we're seeing it's the XLD is in PAL mode, so it's been converted to actually run at 60 Hertz with the correct scaling and everything for this VGA monitor. And I don't know if we're going to need to have a separate solution for European VGA monitors, but it wouldn't surprise me if they actually are for the most part dual mode, being able to run either 50 or 60 hertz. If not, I can always come up with an alternative firmware that tweaks it in for those particular situations. So let's go ahead and bring up a little demo here, so you can kind of get a better feel for what this looks like. Oops, be nice if I spelled it right. Atari. And let's go ahead and run Boink here. I don't have any sound, so please excuse the silence here. But as you can see, the quality is really good. I mean, this is actually pretty darn close to being digital. So hopefully I'll be able to get this project finished up here, maybe about another month, and get some prototype boards made. And if all goes well, then I'll probably release the design at that point. So thanks for watching the video.